Good morning, afternoon, evening, everyone, depending on where you are joining us from. I'm Sam, a software engineer passionate about finding efficient solutions to complex problems, and I'm joined by Nazim and Vlad from the AEM Assets team. Today, I'm going to take you on a journey through the fascinating world of micro-frontends and share how we at the Assets team have leveraged this approach to enhance our front-end development process. We'll explore how we converted our React projects into modular, scalable, and independent micro-frontends, and how this information and transformation has benefited all our customers. Let's take a moment to look at our journey for today. We're going to begin with a brief introduction, setting the stage for our discussion about the evolution of micro-frontend development. We're going to travel from the early days of multi-page applications to the dynamic single-page applications, leading us to the world of micro-frontends that we inhabit today. Following this, we're going to delve deeper into understanding micro-frontends, what they are, how they work, and their transformative impact on the way we develop applications. Next, we're going to discuss the key benefits of using micro-frontends. We're going to explore how they promote language and framework agnosticism, independence, automatic updates, and scalability. We will then take a real-world turn as we delve into a case study of the Asset Selector, one of our recently developed micro-frontends. And then we're going to look at the challenges it faced and how transforming it into a micro-frontend provided an elegant solution. And then we'll dig deeper into how the Asset Selector functions as a micro-frontend and explore some of its potential use cases when we integrated it into other applications. To understand why we chose to adopt micro-frontends, it's important to look at how front-end development has evolved over time. From the early days of static HTML pages to the dynamic and interactive web experiences we see today, front-end development has continuously evolved to meet the changing users' needs and technological advances. The introduction of libraries and frameworks like React marked significant leaps in our journey, enabling more sophisticated content-based development. However, as applications grew in size and complexity, managing these components can become challenging. With multiple teams working on the same code base, coordination and consistency can become a significant hurdle. We saw an opportunity to further refine our development process and better support our teams and customers. This led us to the innovative approach of micro-frontends. The world of front-end development has seen a fascinating evolution. In the early days, we dealt with static HTML sites and very limited interactivity. As technology advanced, JavaScript and CSS entered the scene, enabling us to build more interactive and visually appealing websites. Ajax revolutionized the landscape in the 2000s, allowing asynchronous data fetching, jQuery simplified JavaScript syntax, and DOM manipulation, becoming a staple for many developers. In 2013, React was introduced, transforming the way we build user interface with component-based architecture. And now we're in the era of micro-frontends. Well, probably AI now, but think about Google Maps snippets and how you can easily embed that into your websites. It's self-contained, independent, and incredibly useful. This further evolves the concept of component-based architecture, taking it beyond the bounds of individual applications and providing us with the capability to develop, update, and deploy individual front-end components independently. So what are micro-frontends exactly? They represent a design approach where we decompose a front-end app into micro-independent deliverable parts or components. This decomposition allows each component to be developed, tested, and deployed independently. While together, they form a complete and cohesive application. The key characteristics that define micro-frontends are independence, reusability, and scalability. They encapsulate the principle of reducing complexity by breaking down the front end into smaller, manageable parts. This empowers teams to work more autonomously and efficiently, and opens up the possibility of using different technologies for different components based on individual requirements. Micro-frontends are language and framework agnostic, allowing them to seamlessly integrate into any tech stack. They allow for independent development and deployment. Each component or micro-frontend can be developed, tested, and deployed in isolation, increasing the development speed and reducing dependencies. Thirdly, automatic updates ensure that you're always up to date on the current version. There's no need to worry about manual updates or version control. It's all taken care of for you. Finally, micro-frontends offer superior scalability, and it's not just about handling more users. Each micro-frontend can be independently scaled and based on demand, which is extremely efficient resource usage. If a specific part of your application is under heavy load, you could allocate more resources to just that part of the application without affecting the others. Furthermore, the development of micro-frontends can still happen in parallel. Different teams can work on different parts of the application simultaneously, allowing for faster feature development and improvement. And since micro-frontends are agnostic to the technology stack used, you have the freedom to adopt new technologies for individual micro-frontends as your needs evolve without having to refactor an entire application. So not only does this architecture allow your application to grow as your needs do, but it also enables efficient resource management, faster development, and technological flexibility. This is the power of scalability with micro-frontends. So now we're going to take a closer look at our experiences transforming a React project into a micro-frontend. This project, the Asset Selector, allows customers to access their assets hosted on AEM Cloud Manager. We transformed this from being part of a larger app into a micro-frontend that can seamlessly integrate into any customer project. It's a standalone micro-frontend, making it possible to integrate into actually any application, regardless of technology stack used. By converting this into a micro-frontend, we not only made it more modular and scalable, but also opened up new possibilities for use across different applications. So we're going to dive deeper into the challenges we faced with Asset Selector. First, we encountered significant difficulties integrating the Asset Selector into complex pre-existing projects. This was a hurdle we knew we had to overcome to make the component truly versatile and user-friendly. Second, the Asset Selector was initially limited in its capability. It was unable to integrate with teams using different front-end libraries and frameworks, which was a major roadblock given the diversity of our customer base. Third, the process was manual. The update process was manual. Teams had to update the Asset Selector themselves whenever there were bug fixes or feature releases. This was not ideal, as it required extra work from the customers and could lead them to using outdated versions. But most importantly, being tightly coupled to a particular framework and build system meant that we couldn't allow third party, you as a customer, to use Asset Selector within their applications. In the following slides, we're going to discuss how micro-frontend approach has addressed these changes. To reiterate our process, first we identified a suitable component within our React project that would benefit from being standalone. These were components that could be used across different applications, like the Asset Selector. Secondly, we decoupled these components from the main application. We ensured that they could function independently and had all the necessary logic and resources within themselves. In the third step, we converted these independent components into micro-frontends. This transformation allowed for independent development, testing, and deployment, further enhancing their modularity and scalability. So this visual illustrates how Asset Selector has been transformed into a micro-frontend. We broke down and coupled the application into orthogonal reusable micro-frontends. We refer to each part of our application as chunks. Like a super component, it has its own GitHub repository, its own CI/CD pipeline, and it's deployed independently. They are powerful, self-sufficient entities that update automatically. The consuming products don't need to worry about recompiling and redeploying. So how do these independent chunks come together and form an application? Our Asset Selector is loaded by the browser at runtime using an iframe. This approach provides clear boundaries, making each feature lighter, less coupled, and forces interaction strictly through documented APIs, which ensures consistency and reliability. The modular structure also makes it straightforward to embed into other solutions and products. Now, let's dive deeper into the architecture. At the very bottom, we have the browser runtime. Resting on top of it, we have the unified shell, which is the primary document loaded by the browser, and also Adobe's application that handles authentication and environments, ensuring secure and appropriate access for all users. This shell then loads a full-fledged application, such as Asset Essentials app container, which hosts all of our AEM applications. And as icing on the cake, we have the additional layer, the Asset Selector view, that uses an iframe for seamless integration. Each layer working harmoniously with the others creates a flexible, scalable, and robust application. Asset Selector, as a micro-frontend, has a broad range of potential use cases across different industries and functions. For content creators and marketers, it streamlines the process of selecting and importing assets for new content creation or updates. In the realm of digital asset management systems, it provides user-friendly interface for accessing and utilizing assets directly. For designers and developers, it enhances workflow efficiency by enabling direct drag and drop of assets. It can also enhance collaboration within teams by allowing for direct asset sharing within collaboration tools. For educational institutions or businesses using learning management systems, it facilitates easy access and usage of learning materials. Finally, it can be integrated into email marketing software, which we might show you later, to simplify the process of media selection for campaigns. As you can see, the possibilities of Asset Selector are extensive, demonstrating the flexibility and versatility of micro-frontends. And these are just a few examples. The potential applications of the Asset Selector are as diverse as our customers' needs. Our goal is to provide a versatile tool that can adapt to a wide range of situations and requirements. So now I'll pass it off to my colleague Nazim to talk about how to integrate the Asset Selector within your application.
Hello. Hey, thanks, Sam. Great. So today I'll talk about how we transformed Asset Selector, and now you can actually use that within your application. So the transformation that we've done at Micro-Frontend, it allows us to easily support third-party integration API for Asset Selector. On a high level, this Asset Selector provides a JavaScript API that your application can use to request assets within your assets as a cloud service repository. Asset Selector will provide the UI, the authentication, and the metadata that your assets have, which you can then leverage and integrate within your application. Integrating the Asset Selector within your project is very simple. All you need to do is include the script tag in your application. This imports the Asset Selector UMD SDK, which then you can leverage to render the Asset Selector within your application and get the assets metadata. With the single line of code, you can successfully enable the Asset Selector micro-frontend into your application, making all its functionality immediately available. This underscores our commitment of making micro-frontends not only powerful, but also very easy to use. Let's also take a look at how the Adobe customers to access assets outside of Adobe. So now, if you're to access your assets outside of Adobe securely, it requires an access token, which is obtained through our identity management system, which in short, I'll follow in with mentioning it as IMS. This process may sound complex, but we have built APIs to simplify this process for you. So this Asset Selector SDK will come in built in with all of this management completed for you. This token that you can generate after you call the register Asset Selector service, the token that's generated can be used to obtain the assets from your repository. Here is a snippet. This also showcases like our commitment to ensuring that not only are we making the Asset Selector ease of use, but also making it very secure, or enabling it so that it's secure for you to be able to consume your assets. All right, so let's take a quick demo of how we can leverage Asset Selector. We use internally at Adobe and how you can integrate that within your application. Great. So as mentioned, internally at Adobe, we use Asset Selector with our own application and on-prem managed services instances, including applications such as Workfront, Journey, Sites, and many other products. Let's say for this demo, you're building an email campaign. So we'll go with Weekend as our theme for this. So while building this email template, we want to enable users to be able to get the assets that we have in our Adobe repository. So let's click on this. Once you click on this placeholder, you can see that Asset Selector is making a request, and hopefully we'll be able to get the assets. Great. So as you can see, all of this, I'm logged into this AEM hosted repository, and all of my assets are here. If you take a look at the user interface, we have this main screen of Asset Selector. It's clean and intuitive. You have all of these categories of assets on the left side. You can click on them to extend and kind of just bring up what you have, all of the assets that you have. It's really all of like not that it only includes like these assets as renditions and so on. All of these also includes assets infos and the entire metadata. So some of the metadatas are here, but you can programmatically collect more metadata as well, and you make use cases on them. So let's actually search for, say, this assets. Hey, live demo. Sweet. I actually won. Sweet. I'm able to select that assets, and boom, now it's within this application. Great. So this is very simple. I integrated just a few lines of code. Now I have the asset selector here. Wouldn't it be nice to actually build this? So to start, I have this template project. And when I click on it, it just opens up this empty dialog. And what we will do is we'll load the asset selector SDK and integrate within it. All right. So I have this integration HTML. In this integration HTML, I'll include the script. And what this will do is this will load the script and then inject a global variable called pure JavaScript selectors, which then will have access to all of the asset selector APIs. We'll be able to use that to register services and then render the content from asset selector embed CDN. Oops. Great. Now that I have pure JavaScript selectors loaded, let's take a look. Here, I have all of the available APIs that I can use from asset selectors. We can skip over what this code does. It basically, once you click on this placeholder, it opens up the dialog. And this dialog is actually, when that dialog opens, what we want to do is we want to register the asset selector. So let's write some code. We want to register asset selector. Then when that happens, we want to call the register asset selector service with IMS auth props. So what IMS props basically does is that you define what kind of authentication mechanism you have, what's your client ID, what's your IMS org, and so on. It basically allows you, or you're telling us a selector where to actually find that assets and how to authenticate. So I have this IMS client ID and IMS org that I can pass in to asset selector, so that asset selector knows how to authenticate. So IMS org. These are just org that we created for the demo. So the other thing that this will need is the scope. So as a selector will also allow us to be able to generate the API token that we need to so that we can actually access the assets. This IMS scope and the IMS client ID is sent to Adobe IMS service, which will generate a token for us. We have permission. Great. Sweet. So basically now we have the register asset selector service. When the page loads, we'll actually call that so that the service is registered. Once the service is registered, asset selector can look for this service and know that, hey, there is an authentication service provided. I should use this, and then render the asset selector, authenticate the asset selector user, and then render the assets that belongs to that user. Great. So we have created this service. And the second step that I have to do is now actually render the asset, render the asset selector content. So to rendering the asset selector content, let's see where I want to render it. So where I want to render is here. Asset selector dialog content. Great. So what you can do is, let's get the container. Element by ID. That's the container that we need. And then again, we have the pure JavaScript selectors. Variable available, and we can just say render asset selector with outflow. Sweet. So now asset selector will be able to render the asset selector here. Great. What we need is that we need to supply the asset selector some props. And this props really is for us to reuse what happens when I select an asset. Asset selector will invoke that function when user actually selects that assets. So I have call on close, just leave it this for now, and then say handle selection. So we'll call some function called handle selection. Let's create those now. Right, so I have this function here that basically what it does is when you call the handle selection, it triggers an event, or it starts an event that says on selected event that we'll later use to kind of look into like the asset metadata and so on. So we have that, and then let's actually have this function from here. Let's create on close, just copy over to save some time. Great. We'll also pass in the props to Asset Selector auth flow that we forgot before. Make sure we have everything right. We edit the script here. We've registered our Asset Selector service. And when it loads, we register the service. Sweet. I think that should be it. Great. Okay, so it looks like we forgot something. This is possibly because all right, let's double check what I have. We have the IMS client ID. We have IMS org. Then we have the IMS scope. Oh, we had the function name incorrect. Asset Selector was unable to actually find the service. Great. Amazing. Now, with just those couple lines of code, I have the Asset Selector integrated within my application. Great. So now I can actually, let's go with hiking again. Select an assets. But it doesn't really do anything. Let's actually generate some rendition real quick. So how do you actually generate a rendition? So earlier we invoked the event call on asset selected event. Let's see what that event looks like. Create a function here. Say on assets selected event. This will give me all of the asset that's selected, right? You can say just be structured detail because we're passing in as a detail here. Just console log what detail we get. And let's register or listen for an event call. In the type of event that we called it on assets selected event, event we created. And then we should be able to see all the metadata. Again, open it up. Hiking. Sweet. We see all of the metadata for the assets, all of the status of the assets, computed metadata, the size of the asset, the date, who modified it, who created, and all of the good stuff. Now, what we're actually interested in the rendition of the assets for this demo. So where the rendition is available is under the rendition tag, and you have all the available renditions that's available for the assets. So I have this quick, easy function here that'll, what it will do is it will really just look at the asset and kind of generate like the preview of the assets. So how do we actually get the rendition? So let's create a function called generate preview image. We'll say generate preview image, and it will actually take the asset that that we just received, and then just get the first asset. So assets that we received, the first item that's received, and then look through the asset link that we had available, right? And then call the rendition key within the dictionary. Sweet. Yeah. No collation there. Sweet. So that actually gives us the rendition link. All right. We have the rendition link. Now, with that rendition link, what we want to do is actually get the optimal rendition. And you can hard code this, but I have this quick, really easy, basic function that calculates the optimal rendition. That basically just goes over each of the renditions and get the highest, the image with the largest width and height. Assume that's the optimal rendition for now. Great. So we'll say optimal rendition. Got optimal rendition pass in rendition link. Oops. And then after I actually have the rendition link, I'll be able to use that link to actually generate the blob that I can then render. So what we'll do is constant rendition blob. And then the rendition blob is, we won't say that rendition blob pass in the optimal rendition. Create that function. takes rendition blob as an input. Right. So this will be an async function. So the way to actually get the rendition is you have the IMS token that Asset Selector generated for you. You can actually now generate a rendition blob by passing in that token that Asset Selector initially generated. So how we'll do it is we'll create a response. For the sake of time, I'll kind of just copy over from like the template code we have. By the way, all of this code is available in GitHub. You'll be able to use it through the Adobe short link that we have in the next slide, or be able, right, and then go to GitHub and access the code there. So basically what this will do is it will create a fetch request and pass in the token and then generate and return you an object URL that you can use for rendition. And then let's copy over a little bit more code that we have here that will all be very useful for you to be able to look through how this was done. But basically, the gist is that it will make a fetch request, get the with your credentials that as a selector generated, and then generate a rendition. Sweet. So great. Let's see what you got here. Again. Right. To get URL. So one more time. Sweet. Okay. So as you can see, you're successfully able to make the request, but it's fulfilled, but it's incorrect. All right, let's see. All right. Where are we going wrong? If the oh, okay, right. So live demos are always, live coding session is always great. You're getting the rendition blob from the rendition link. Oops. Select this asset. So what's wrong here is that we are not passing the correct link. So let's debug what link we are actually passing here for rendition link. So what this should look like is null there, case. This should work. Sweet. Hopefully, fingers crossed. Right, one more time. Okay, great. So we're still passing the incorrect URL. Wrong window. But anyway, that's such a fail. But we have the entire code available in GitHub. So you'll be able to go here and then go to vanilla JavaScript and look at the integration JavaScript and look how this rendition and everything is generated here. Sweet. For the sake of time, we'll stop debugging here for now. Live debugging is always hard. So really the next thing that we want to focus on is how great the Asset Selector SDK is, like what it enables for you. So as we saw right now that we integrated within the vanilla JavaScript if you have, but it is also available within your React or Angular or any kind of framework that you can think of. Asset Selector SDK is framework agnostic. So if you take a look at how this implementation would be in React, same thing, same step. You have the register asset selector auth service, and then you have the asset selector auth flow that are both available within React. You will simply have to import those from this ESM CDN. We have, instead of a JavaScript function, which is also available for you within React, but we also have an exported name exported function called asset selector with auth flow, so that if you're using JSX, it's really usable for you within JSX. So great. And yeah, that's the true strength of Asset Selector. As a micro-frontend, it allows you to seamlessly implement Asset Selector within your environment. You can think of implementing it within JavaScript or any other framework you can think of. What you see here is really just the beginning of embedded application as a micro-frontend, such as Asset Selector. What's next for Asset Selector here on out, if you implement it within your application, is that Asset Selector will automatically receive updates and improvements. You as a user won't have to worry about manually updating the component at all. This means that you, as our customers, you will always have access to the most up-to-date, futurist version of Asset Selector and able to integrate your assets from DAM that lives in Adobe within any of your other applications. We believe that the Asset Selector as a micro-frontend has unparalleled versatility and efficiency really to the way that you and our customers consumed and create digital assets. Thank you. With that, we'll take Q&A. Any questions you have?
All right, thank you, everyone. I think we are out of time actually for Q&A, but that's all right. You can go ahead and head to that link on Experience League if you have any, and Sam and Nazim can answer them for you there. So thank you very much.